We're on day 25. And today we're going to finish up our Peter Pan story, Imaginary Land Complex Numbers. And I just want to see if you guys remember what we went over last Wednesday. So last Wednesday we went over adding, subtracting, and multiplying of these called complex numbers, and we introduced the letter I. Do you remember that?
Mm-hmm.
Yes or no?
Yes. Yes.
Everybody? Okay, so with your partner or your group, you guys sort of work together for me today. And you guys sort of work together for me today. What I want you to do is to try to add these complex expressions together, subtract them and multiply. Work with your partner and just try those 3 problems just to get your brain warmed up, and because today we're going to do divide, so we got to keep going, but you got to remember what we did last Wednesday. So just write on this front cover, you just write these 3 problems and see if you remember how to do adding of imaginary numbers, subtracting, and multiplying. Good morning.
I'm exactly halfway done with the homework.
Wow. Turn around and work with whoever's near you. If your partner's not here, you guys be a person today and further come. Forget your notes.
Is that what you got?
Just try these 3 problems and see if you can warm your brain up to imaginary numbers like we did last Wednesday.
How did you do that?
Equals -5. This is a lot like one of the first things we just ran into here where I'm like, huh, those don't fit. So then how about 7i equals -5?
So yeah, and then you do the box method for the last one.
Why can't you guys ever just say distribute? See, this is bad for you.
The box method is just stuck in my head. You know?
Okay, what
Think
work
outside
are
the
we
box.
going to show for the first problem over here?
Minimal.
Minimal, that's right. We're going to use our eyes, and we're going to use our definition of like terms. Remember that? And some of you might be underlining the like terms, some of you could be circling them, some of you could be highlighting them. But what you're going to do is we're going to combine these like terms, but we put the real number part first. So we're going to put 5 first, and then we're going to add the 3 and the 4, the coefficients of our imaginary parts there, and get 7i. Everybody got it? Yes or no?
Yes.
Answer.
Yes.
No. Angel, welcome. Okay, we're going to try the second one, and what's different about the second problem up there?
Subtraction.
We got negatives or subtraction, and it's what kind of work are we going to show for that one? Minimal again. We're going to use our eyes, and we're going to pay attention to our like terms. We're going to put the real number part first, and then we're going to add the -3, the -4 gives us the -7 of those eyes. Easy peasy? All right, next one, what are we going to do?
Box method.
Multiply 4.
Foil, one way, what's another way?
Box.
The box. I don't care which one you use the Barbier method or you use foil, either way. Again, I like the box method because then I know when I'm all done with the problem, all 4 boxes need to be filled inside here. And it's the same as foil, but it's just a nice organizational way of doing your first, outies, innies, and lasts. And we gotta combine like terms again. So what do we have for the first box?
12.
Second box?
69.
Nice. Third box?
It's -59.
And last box.
Negative
We can
20
solve by
as per
factoring.
second power.
We can solve by factoring.
Yeah.
Okay, and again, if you use the box method, you can go eat dinner, you can go out and watch a movie, you come back and you know you gotta fill in those boxes, and it's sort of a nice, easy organizational way to get all your terms. What does I squared equal? Do you remember that from last Wednesday?
Negative.
Negative.
Angel?
-1.
-1. So this guy right here is a -1 times a -20, what do we get?
Plus
Positive
20.
20. Combine the diagonal, we have 32. Combine the other two diagonals, we have what?
Negative 1.
-1, we have our like terms there. So we have 32 plus 1i.
One horn flying purple people eater.
Yes. Any questions on add, subtract, or multiply? You gotta remember this in order to do today's lesson, because today's lesson, guess what? We're gonna be adding, subtracting, multiplying, and learning how to divide these complex numbers. Again, this is a slide from last week. It's the one I showed you when we started our complex numbers. And these two things you need to memorize or have written real big on your wall somewhere so that you remember that if we have an I, that means there was a -1 inside the radical. If you have two I's, it equals what? Multiply together?
Negative.
Negative what?
1, I'm sorry.
-1, good job. Okay, so let's review and see how well you remember how to simplify a radical that has a negative number. Again, with your partners, see if you can give me the answers to these two problems.
Okay, it is, no, it isn't. I got the wrong number. Wait,
So you bring out the
yes, I got the right number. What?
You bring out the negative first and negative times into a not imaginary, so we bring that out. And you can go ahead and get the radical, which is 7, of course, but it would be 7i instead of -7.
Is this yours?
This doesn't say it has an imaginary.
Because remember, a negative, so a number can't be under.
Okay, remember we can't have radicals, or can't have negatives under our radicals, so what's the first thing we have to pull out?
Negative.
The negative, and it comes out as an
Imaginary number.
I. So I have to pull out an I, and now I can play with my rules of radicals. What's the square root of 49? 7. So my simplified answer is?
3.
Is what? What's going on? 7i.
Mhm.
Okay, next one.
Bring out the negative.
Pull out the negative. Now I've got radical 27. If I look on my multiplication list, 27 doesn't have isn't perfect square, but does it have perfect square factors? Remember this?
Yes.
Okay, what number is perfect square factor in there?
9, 3.
9. 9 comes out as a
3.
3. And so again, you can put 3i in front of your radical, that's where I put it, or you can put it behind the radical, but what happens is it looks like all of it's underneath the radical, so we sort of like putting it out front. Okay, that's a review of what we did last Wednesday. Now today we're going to do some new material. The new material is called dividing with our complex numbers. You guys remember the word conjugate? Yes or no?
Yes.
Raise your hand if you remember the word conjugate. We covered it a couple times. Conjugate. What's conjugate?
Oh.
Ooh.
You take the opposite of the sign that comes with the problem. So if you have minus, you add, you make it plus.
Okay, and how many terms do we have?
So
2.
2. So, watch. Conjugates are two binomials. Remember we talked about this? They're like twins, but one's a boy twin, one's a girl twin. So we have one plus and we have one minus. And what happens when we deal with conjugates is we get a nice simplified answer here where we lose that middle term that you guys keep forgetting about, right? So watch, if I have A plus BI and A minus BI, do the box for me on your paper. Make a box and multiply those two together. Yes, Angel.
For the bottom right box, would it be B or B squared?
B squared, because
Squared.
you're doing B times B. Good question. Do you remember when we dealt with conjugates before and I said you can do the first term, that's nice and easy. What happens to these two diagonals when we use the box method?
They can't cancel.
Cancel
They
that.
cancel out every single solitary time when you're dealing with conjugates. Okay? And so this box here is a positive ABI, and this box down here is a negative ABI. So these guys always cancel out. So all I have to worry about is the first term, squaring it, square the second terms together, and then I have I times I, so I have to be careful. Neg B times B gives me what? Negative B squared, but then I'm multiplying it by I squared. What's I squared equal to? Neg 1 again, remember that? So now I have a negative times a negative gives me a positive B squared. That's where that comes from. Conjugates are really fun. Do we have to show a lot of work for that? Not after a while. When you get used to multiplying conjugates, you know that you multiply the first two terms together, multiply the last two terms together, put a plus sign between it. All right, try this guy with the box method. Just to solidify it in your brain, making sure you understand what those diagonal terms are going to do.
Which one?
Number 1.
I don't think I have that problem. Oh, you know what? I solved that one.
I did.
Yeah, that's what I was doing for the last
That's
one
what I was
too.
doing for the last
Okay.
one, yeah.
Nice, you're ahead of the ball game here.
The one on the bottom left.
This way. On your paper for your work, you should be proving to me why your answer is 117. Can you see where we got 117? How did I get 117? What's negative 9 times negative 9? Negative 81. And then I have I times I, which is I squared, which we know that I squared is another negative 1. What's a negative 81 times a negative 1? Positive 81. So these two add together give me my 117, and those diagonals should be negative 54i and positive 54i. They're going to cancel out because they're conjugates. We love conjugates. Makes our math easy. All right, when we divide complex numbers, how do I know I have complex numbers? Because I see Mr. I, and he's in the denominator here. I want you to discuss with your group. You need to divide by a complex number. You multiply the numerator and the denominator by the conjugate, ooh, I'm using that word again, of whatever the denominator is. So now you gotta come up with what's the conjugate piece. So with your group, decide what goes on top here, what two binomials, one on top and one on bottom, should I be writing? This is called work. I need to see this.
So
Show your partner what you got.
plus I plus I.
We're gonna do that with the numerator, I believe, so it's gonna be both top and bottom times, 3 plus I.
Yep. Yeah, so, yes.
Is the conjugate, you multiply by the conjugate.
Okay.
The conjugate, basically, you look at the bottom number, right, and you look at the sign, you basically flipping the sign, that's all you're doing. Yeah. Flipping the sign and multiply by the conjugate.
That's plus? Yeah. Talk to your partner. Help them out. Okay, did we all get the conjugate?
Yes.
What work did that take? Not a lot. It took our brain thinking about what's the conjugate of 3 minus I. I gotta put 3 plus I. Now when I get my denominator and I'm going to multiply it out, what happens with the i's? I'm not gonna have any i's because when I do 3 minus I and 3 plus I, again, if you wanna show the work, these two are gonna cancel out and you're just gonna have a 9 here, and then I times I is negative I squared. That means -1, so what's the opposite of -1? 1. So these two added together will give me this 10. Do you see where the 10 comes from? And now we take a big sigh of relief. I don't have my imaginary numbers in the denominator again, because I can't have imaginary numbers in the denominator. Can't have radicals in the denominator, what we went over last week. So what I want to do is just have a little number there if possible. So I got my 10, but what do I have to do on top?
Multiply.
You gotta multiply them together. We have two binomials on top. So again, if you can't do it foiling in your head or on your paper, you should be doing the box method again, because it gives you a lot of time to think about what you, your multiplication and what you gotta put down as far as combining like terms. So I have 3 times 23 is 69, correct? 3 times neg I is negative 3i. I times 23 is 23i. And I times neg I is a negative 1i squared. What does that give you?
That'd be a 1, positive 1.
Positive 1. So now we have 1 plus 69. What does that give you? 70 plus 23i all over what? 10. Did they make a mistake?
No, you forgot to subtract -3 from 23.
Yeah.
Oh, thank you. Uh-oh.
Yeah.
What do you guys get?
That's the point.
5. Nice, good job. Okay. Are we okay with that one?
Mhm.
Okay, let's go to the next slide. The next slide is sort of an interesting kind of slide. And what I've done is I've color-coded it for you. So if you got your markers out, that might help you see this pattern. If you got an I, you know you're in imaginary land, right? You got Peter Pan working here. If I have an I squared, we know is -1, correct? Well, what is I to the third equal? Gee, I don't know. Well, if I broke it down to I squared times I squared is what? -1. -1 times I is neg I. Do you agree? Well, if I have I to the fourth, I could break it down to be I squared times I squared. Do you agree? Add your exponents. That's -1 times -1, which gives me a +1. Now you're going, okay, my math problem says simplify I to the 55th. I don't know
What is
that
just I?
I,
Yeah.
what, it says that you had a -1 underneath the radical, remember?
Well, what is I? What is I?
I represents having a negative underneath your a -1 underneath your radical.
Oh, okay,
So
alright.
that's what it represents.
You're
Okay.
wondering
Yes.
why R1 isn't just equal 1?
Yeah.
Yes.
Yeah.
Oh.
Do you want me to simplify?
No, oh, no, wait. Okay, what is I to the 55th power? Your job is to tell me, is it 1, is it -1, is it I, is it +1? What the heck is it? So if I continue this pattern over here, I have I to the 5th, that equals I to the 4th, and then I have one extra I. Do you agree? We already know I to the 4th is just 1. So 1 times I is just I. Now, what's I to the 6th? Well, again, that's I to the 4th times I to the 2. Do you agree? I to the 4th is 1. We already went over that. I squared is -1. 1 times -1 is -1. Do you see the pattern repeating itself? I have a yellow I, a green -1, a beige -I, and then a blue 1. Every 4, I go through this cycle. So to do this problem, I to the 55th, I could sit and write I's down 55 times. Raise your hand if you want to do that. Nobody? No, we don't want to do that. Takes too long. So every group of 4 of these will give me a +1 factor. Every group of 4. So what you're going to do when you hit these problems on your homework where it says simplify and they give you an I to an exponent, you're going to divide the exponent by 4. And once you divide by 4, you're finding out how many groups of 4 are in that number. And again, whatever number that is, it's just being multiplied by 1, because every group of 4 is just a factor of 1. So what you want to do is find out what remainder you have. So what you want to do is divide the exponent by 4. So I want you to try that on your calculators. Do 55. Do 55 divided by 4. What does your calculator say?
10.75.
13 and some change. Nice. That 13 is telling you how many groups of 4 are in 55. There's 13 groups of 4. But you want to find out what's the leftovers. Do you have 1 leftover, 2 leftovers, 3 leftovers, or 4 leftovers? Now, if you use your calculator, you want to write this down next on your notes. If you get a 0.25 leftover, the change, that's going to be an I. If you get a 0.50 or a 0.5 is -1, 0.75 -I. If you get no remainder, then it's a 1. Some of you are going to do long division, and that's perfectly okay too if you do long division. If you have a remainder of 1, your answer is going to be I. Remainder of 2 is -1. Remainder of 3, neg-I. Remainder of 4 is 1. So if I do this problem, what's my remainder? Point what?
75.
.75.
What's the,
And so what is the answer? Means you have 3 i's left over. 3 i's left over will be a negative I. If your calculator says .75, that's like 3/4, right? Same thing. You're gonna have neg I. Okay, try this one. I to the 98th power. Try it on your calculator. Tell me what my answer will simplify to. What we're looking at is what's left over. When you divide 98 by 4, you're finding out how many groups of 4 are in there. And it doesn't matter how many there are, it's being multiplied by 1, so it's just a 1. But what you want to do is find out how many extras are beyond that group of 4. What's the answer?
It's only 4.5.
0.5.
Yes.
So if it's a 0.5, that simplifies to be -1, because you got 2 i's left over. Remember, I squared gives you a -1. So what work are you going to show me on your paper?
not a lot.
Not a lot, right? You're going to show me either your answer to your division problem, or you're going to do your long division and tell me what your remainder is. Okay, let's review where we've been so far. This is our family tree of all the numbers that we've covered so far this semester. Every one we've covered this semester, we started over here in this red circle, then we went to fractions. Remember how much you love fractions?
Never.
Don't give me a bad look. How many of you love fractions now? Me too. Okay, you guys know LCD. You can get rid of those fractions now. You should like fractions. I see a few smiles. That's better than the first day of class. Okay, all right. And then we went over here into our complex numbers that we've been dealing with for the last 2 days. So in our complex numbers, you should know how to add, subtract, multiply, and now divide complex numbers. You should be able to multiply and divide them, and then you should know that when you square I, it equals -1, correct? Okay? And you need to know what conjugates are. Any questions on that? All right. We're sort of done with imaginary numbers, but now we're going to go into our last phase for the whole semester for this class. This is our last little hurrah. And guess what we're going to do? We're going to solve some problems again. So go to your next slide. And I'm going to take you back past Never Never Land. We're going to go back to exam number 2. You guys remember your exam number 2? Shake your head if you remember exam 2. Yes? Okay. So we remember exam 2. Look up here. You might want to highlight this in your notes. But exam number 2, you had to solve every equation I gave you with the squared term by factoring. Do you guys remember that? You remember this guy, Mr. Exman? Say yes?
Yes.
Yes? Okay. And you had to get that equation equal to 0 in standard form. You remember that? And then we did the X-Men and we found out what 2 numbers multiply together give you the bottom, what 2 numbers add together give you the top. Do you guys remember that?
Yes.
And then you had to get this, and then we had to put the word or between it, or I took off the point. Does that sound familiar? All right, guess what? We're not going to do that anymore. I'm going to show you in the next 3 class periods 3 different ways to solve this exact same problem with half the work. Raise your hand if you like that idea.
I love it.
You love it. Nice. Good. Okay. So watch. When I give you a math problem that has a squared term in it, a squared binomial in it, we don't have to do all this work. Really? Why'd you make me do it? Because that was the level you were at way back when. But now we've expanded our brain into radicals and imaginary numbers. So now I can do lots of different problems that I couldn't do about a month ago. All right, so watch. There's basically 4 steps, but I'm going to show it to you by colors. Step number 1. You want to get the binomial term isolated on one side and the number on the other side. Did I do that?
Yes.
How hard was that? You like that one? Come on, guys.
Not
This is a
hard.
piece of cake, right? So we're just adding 7 over to that side. Life's good. I don't even need my calculator. All right, that's step 1. Isolate the square term. Step 2, take the square root of both sides. Well, how do I take the square root of both sides? See, I couldn't have taught you this method a month ago because you didn't know how to play with square roots. The only thing new today is this piece right here. You have to remember to put a plus minus on the number side. Because remember, when I do square root of 49, it could be 7 times 7, or it could be what?
-7.
Negative 7 times negative 7. So the new part that you have to remember is to put this guy here. So this is hard to remember, so put a little arrow by that in your notes and put a little star, highlight it if you want. All right, now, remember the shortcut I gave you 2 class periods ago when the index and the square match, what do you bring out?
Yeah. The number that's inside.
The radicand.
The radicand, nice words. Yep, we bring out the radicand. Did I have to do any work? No, my brain had to remember that. And now I go to the other side, and over here, I have to go through my 3 rules of radicals. Do I have any perfect squares underneath the radical? Any factors? Is there any imaginary numbers underneath there? What's the square root of 49? 7. So now I put plus or minus 7. Easy peasy. So take square root of both sides. Remember to put plus minus in front of the number side, the constant side. And now we're going to simplify. We've already done that last week. And now I've got to figure out this answer. And again, the bird beard does weird things. I go the high root first. High root means you take the high sign. So neg 4 plus 7. What do you get?
3.
I owe you $4. I have 7. What do you have left?
3.
You have 3. Now you take the low root. Neg 4 minus 7. What do you get?
11.
Negative 11. And you put your 2 answers in the funky brackets. Look, this is what you did for exam 2 for me, where you got your scores on exam 2. Here's what you're doing on exam 3. Which one you want to do?
They're both easy.
They both should be easy, right?
Yeah.
And what Pima wants you to do is to be able to solve by factoring and solve by square rooting. They want to see both. Now in exam 2, some of you solve by square rooting, and I put, read the directions. It says solve by factor, and I took off points because you weren't showing me that you understand how to solve by factoring. Factoring, I should see your X-Men. Solve by square rooting, I should see your square roots to both sides. You see how your work is gonna tell me what strategy you're doing. Okay, now let's look at what,
On the final, does it matter which one we use?
you mean here?
Yeah,
Oh, you mean
Which
which
method?
method?
yeah, which method?
It'll say solve by factoring, or solve by square rooting, or solve by the quadratic formula, which is what we're gonna go into next class period, yes.
If it says solve by factoring and you solve by squaring because you don't read the instructions, is that a point or two off?
What would you do?
I would do whatever I'm currently learning.
If he was grading,
Yes.
what would you do if you were grading it?
Uh-huh.
Maybe like, let it pass. As long as the answer's.
He's
right.
nice.
Angel's my feisty one in the group here, yes. If it says solve by factoring and you don't, or it says solve by square rooting and you don't, then I am gonna take off points, but I won't take off all points if you get the right answer. But you wanna read your directions always very carefully, right? Okay, now let's look at these guys.
Or we're gonna skip this one.
Like no
Yes,
smoking, I'm glad
skip
that
that
sign's
one,
there.
yeah. Okay, skip the next slide. We'll go back to that if we have time. Go down to the bottom there. It says, okay, Angel, read the directions.
Solve the quadratic equation using the square root property.
Okay, we got it? So I don't want you to multiply that all out. I don't want you to get it equal to 0. I want you to just solve by square rooting. Is the squared term by itself?
Yes.
What?
Yes? Is the squared term by itself on one side?
Yeah.
Yes.
Okay, do I have the constant on the other side?
Mm-hmm.
Yes. Okay, what's my first step then?
Square.
Square root in the right side.
Nine
You're gonna
squared.
square root both sides. And don't forget that plus minus. It takes a little, how many times do we have to do something before we
7
remember?
times.
7.
Okay.
7. So we've only done it once, so you have 5 more times. So you want to square root both sides. Then I bring down my x minus 4 equals, and then I have plus or minus square root of 180. Well, square root of 180, now I've got to go through my radical rules and say, does it have any perfect square factors?
Mm-hmm. I mean, yeah.
What number goes into it? Real easy.
10.
10 does. 10 times 18.
Mm-hmm.
What else?
90 times 2.
9 times 2.
Or 90 times 2.
2 times 5. Do I have any partners in there?
Mm-hmm.
9 and 4.
What? 9 and,
2 times
Mm-hmm.
yeah. 9 can come out as a 3. Got a pair of 2's underneath the radical. Do they get to come out and play?
Yes.
Come out as a 2. 3 times 2 is 6. And so I'm going to have this negative 4, which has got to go to the other side, plus or minus 6 radical 5. You see, we couldn't solve this problem a month ago because it's not factorable. It won't be factored into 2 binomials because we don't have the right numbers. A month ago, I always gave you problems that were factored really easy and nice and a piece of cake. Now, you've got to sit and break down that radical in order to not break any of the 3 rules we went over last week. Okay, we're going to go to the next slide. We'll come back to these if we have time. All right, so one way we can solve these is by factoring. Don't want to do that anymore, at least for a while. We want to square root both sides, right? Isn't that an easier way? But look at the problem I'm going to give you for homework. What's wrong with it?
It's equal to 1.
It is equal to 1, but that's okay when we do square root to both sides. But what's wrong with this one? You gotta understand what's wrong with it and what you gotta do in order to make it nice.
It's two variables.
No, they're not.
To what? Not variables, to
I know.
binomials. Good job. Two binomials,
What's the
and
problem?
they're not a perfect square. Look, I have an x plus 6 and I have an x plus 4. You go, I need either an x plus 6 squared or I need an x plus 2 squared. You're going, oh, Barbier, you're getting hard on me again. This is not fun. So this is one of the hardest problems you're going to do for homework. They're going to say solve by completing the square. If you read in the book, look.
We're looking.
Yeah, it's not fun. But now I'm going to show you the Barbier method. Step number 1, you want to check 2 things. You want to see if you have a binomial squared. I don't. So if I don't have a binomial squared, what I'm going to have to do is FOIL those 2 binomials. So put a little arrow down there and you got to FOIL it. Either in your head, the box method, or you can do FOIL. I don't care which. Do you know how I got the x squared plus 8x plus 12? Yes or no?
Yeah.
Yeah.
Yeah, I did the box method, or I did FOIL in my head, first, outies, innies, and last. And it still equals 1.
But we'll lose points if we factor, if
No.
we, okay, no, but that is how you got your trinomial, okay.
Yep, good terminology, great job. Okay, they want to make sure that the second degree term is a 1, is it?
Mm-hmm.
What did I do to get that answer? I used my eyes, not hard. So the first term has a 1. Step number 2 is I have to get it in proper form, correct form. Correct form means that I want to get it equal to 0 like I did before. So I subtract 1 from both sides. You can do that on your paper so you see where the 11 comes from. But proper form in this new method is not just getting it equal to 0. What you want to do, proper form, is you want to make sure all the variables are on one side and the constant term is on the other. Did I do that?
Yes.
Oh,
Now, when I used to teach this in Illinois in high school, I used to sit and make the students put a dash here and a dash here. And take off points if they didn't show me their spacing. Okay? What you're going to do is you're going to do the next step, number 3, and it's called complete the square. Our job is to get a binomial and have it 2 binomials that are exactly the same, or a binomial squared. This isn't, so I'm in trouble. It's the hardest problem you're going to get. So what do I have to do? Step number 3.
Take half the coefficient.
Take half of the first of the linear term, this 8.
yeah.
Put a box around it, a circle around it. Put a star by it. Mr. 8, I'm going to play with you in step 3. So in step 3, I take half of 8, or you could divide by 2. If you just want to use your calculator, divided by 2, that's the same as multiplying by a half. And I want you to get the number and put it right here. Was that hard?
No.
Okay? Now the second part is you want to square this number. What's 4 times 4?
16.
And you're going to put that here. Now we're going to use those 2 numbers, the 4 and the 16, in our step number 3. What we're going to do is we're going to put an arrow. The 16 is going to go in the 2 boxes that we made up here. So I'm going to put a 16 here and a 16 there. Now what do? Step 4. Step 4, you're going to get a binomial squared. X squared plus 8x plus 16 equals x plus 4, the quantity squared. You're going to use your 4 from here and put it in the binomial squared. Really? Yep. You're going to use the 4 and you're going to use the 16. We put the 16, the squared number, in our original problem, and we need to find this new number here. On the left side, this will always, because you built it that way, to be a binomial squared. Now I have x plus 4, the quantity squared. I add these two together, and that's where the 5 comes from. Uh-huh.
Would step 4 be the final answer, or would it be the answers below?
Step 4 is going to be all this work. You're going to get your binomial squared, like we did for the last slide. You're going to start with what we did the last slide, equal to a number on that side. Now we have to square both sides. Don't forget to put a plus minus. When I square root a squared term, I get an x plus 4 equals positive radical 5 or a negative radical 5. Now I add 4 to both, or neg 4 to both sides, and I get negative 4 plus or minus radical 5. This problem you couldn't have solved a month ago. You would have said NF. Remember when we used to say NF not possible or NP not possible? Now they're all possible. Okay. With your group, by yourselves, I want you to solve this math problem that I have here. X squared plus 10x minus 3. Now I've only shown you one problem, but what I've told you on the other side is when you do your homework and you get stuck, you can read the right side and it'll tell you what you needed to do. So step number 1, I checked to see if I had a 1 in front. I do. And then I made, remember how I told you with my class, I used to make them put slashes on the left side, right side, so this is going back to when I used to teach in Illinois. But I used to make them, I want you to make extra room for our new binomial squared that we're going to make. So I put the dashes on both sides, and what did I do? I moved the constant to the other side. So with your group, tell me what's underneath that first box. What should I write? Right here.
3.
All together.
3.
All together.
3.
That's about 5 of you. All together.
3.
That's not too bad. A 3. So all you're doing is getting the constant on one side and you're getting the variables sitting on the other side. Now step number 2 I call the work box. This is where you got to show me how to get 2 very important numbers. What's half of 10?
5.
And what's 5 squared? 25. So this is called your work, and you're going to show me these steps so I know where you got your 5 from and where you got your 25 from. Now the green number, the 25, goes in this statement there. And what's my binomial squared?
X plus 5.
X plus 5. We use the blue number here to go in the binomial. These 2 guys are really important. They help build my problem because I need to add 25 to both sides, remember, to keep our equations balanced. And then we need to have our binomial squared, because once I get this binomial squared, the rest is a piece of cake. Okay, what do I have to remember to put next to my radical 28?
Plus minus sign.
Plus minus, how many times have we put the plus minus down?
4.
4. How many do we have to go through?
3.
3 more, why?
It's like 7 times the or something.
7 times, we'll remember. Okay, so we need to have a plus minus in front of the 28. Once you get to this step, what happens? The index is a 2, the square is a 2, what comes out? Radicand, plus or minus 28. Again, 28, I gotta sit now and go through my 3 rules of radicals. Do I have any factors underneath there that are perfect squares? Do I have any fractions? Do I have any negative numbers underneath the radical? I have 28. What is 28?
4 times 7.
4 times 7. 4 comes out as a 2. So my final answer when I get Mr. 5 to the other side is neg 5 plus 2 radical 7, neg 5 minus 2 radical 7. Now you can write it this way and put your plus minus and just write it once if you want or twice. I don't care. Yeah.
So we don't need to do x equals this or this, we're just do plus minus?
Say that again?
Exactly.
So plus minus is good as the answer?
Yes. But you have to know that there is 2 answers here. And if I ask you to write the 2 answers, I just go the high road first and then I do the low road. So I hit the sign that's on top with the second term, hit the sign on the bottom with the second term. Okay, are we good so far? Yes or no?
Yes.
Little shaky? Have I given you the hardest problem that's on your homework?
Yep.
You think so?
Hope so.
You hope so, yes, but have I?
Probably not.
Gabe, have I? Probably not, right? All right, we got one more problem to do, and I'm almost done with you, almost done. I know your brain hurts. This is the hardest problem you will have. It's this guy right here. Put a box around him. What's wrong with this guy? I haven't stressed it a lot because all the other problems I've given you were quote unquote
Oh.
easier.
Doesn't have a leading 1.
Very good, Tim. Doesn't have a leading 1. So what's the first thing I did is I divided everything by 2, and I'm lazy, so I brought my 3 to the other side, so all my x's are on the left. Do you see that? And I brought that negative 3 over to the right, so I'm adding 3 to both sides, and then I'm dividing everything by 2. Is dividing by 2 hard?
No.
Not too bad, right? These cancel out, that's why we did a 2. If there was a 3 in the front, what would you divide everything by?
3.
Okay, 12 divided by 2 is? 6. And there I go, here's my Illinois patterns coming out of my brain. I always, when I want to solve by completing the square, put a plus blank, plus blank, because what happens is you forget to add the blank on the right side a lot. So I always do this, so you might want to put arrows there so you remember in your notes. Now, what number am I going to play with in my workbox?
6.
Mr. 6, this guy right here is going to come over to my workbox, and I need to get 2 numbers in my workbox. You got to show me how to get those 2 numbers. What do I do first with 6? Divide it by 2. What do you get? 3. And then what do I have to do for the second part of my workbox?
Square.
Square it. This isn't hard. 3 squared equals 9. Thanks. Okay, So I'm gonna use these two numbers for the rest of my math. Did you hear me? I need to put the squared number into the original problem where I put these blanks. Now, if I was doing this on my own paper, I wouldn't rewrite it. I would have just put a 9 here and a 9 here. And then I wouldn't even have this step. And then I'd go right to my binomial squared. When you go to your binomial squared, you use this number here, the 3, in the binomial squared. You see how your workbox is going to help you get the rest of the math problems. Now I've got to square root both sides. If I square root both sides, what do I have underneath that radical? Oh no, your favorite thing. What is it? What is it?
Fraction.
No, it's your 2-story house. Remember from Illinois? Yeah, you got a 2-story house.
Denominator.
Remember that rule? Right? Underneath the radical, you can't have 2-story house, especially if you're living in Arizona. Too hot on the second floor. So we got to break it down to 2 what? Condos. So I have to do radical 21 over radical 2. Now what? Oh, my bottom condo can't have a radical. So what do I have to do?
Rationalize.
Oh, look at those words we're remembering. 21 times 2, that's where the 42 comes from. All over 2. Now I get Mr. 3 to the other side as its opposite, and then you have -3 plus or minus radical 42 over 2. That is the hardest problem you will have. Yes.
Did you not bring out any numbers from the radical?
42, you mean?
Yeah.
42 is what, 6 times 7? Neither of those have any perfect square factors underneath. If you think of one that I haven't, you might get more extra credit.
This is over
No?
2, then why can't it
Okay.
be just radical
All right,
21?
I'm done with today's lesson. You got 15 minutes to work on your quiz. This is an individual quiz, so you need to work and show your work for those 5 problems. If you want to stay and do the practice quiz, I'll be happy to do that. I'm going to work with you in a minute. As soon as you're done with your quiz, let me know. Any other questions? Okey-doke.